Hello guys, in this video we will discuss about some basics of matrices. We will start with the definition of matrix, and then we will discuss different types of matrices, and then some concepts related with matrices, and then we will see some operations on matrices, and we will finish this lecture with the special types of matrices. So let us begin with the definition of matrix. So matrix is what? Basically matrix is an arrangement of objects. So matrix is arrangement of objects in the form of arrays. For example, so this is an arrangement of numbers in the form of arrays. So these numbers in horizontal lines are called as rows, and these numbers in vertical lines are called as columns. So these are rows and these are called as columns. So if you see here in this particular example, you see that we have 2 rows and 3 columns. So we say that this matrix has 2 rows and 3 columns. So here we will say that A is a 2 by 3 matrix. What does it mean? It means that this 2 by 3 denotes the size of a matrix. So this first number in the size is denote the number of rows in that matrix, and the second number in the size or the dimension of the matrix denotes the columns. So in general, if it is written that you have a matrix B of order 4 by 5, what does it mean? It means that this matrix B has 4 rows and 5 columns. So this is called as size of a matrix. Just let me give you the standard notation for a matrix. Suppose you have a matrix A of order m cross n, that means having m rows and n columns. So we write at the first place, this is first row, first column entry, so we denote it by A11, first row, second column entry, first row, nth column entry. Similarly, mth row and nth column entry. So this is the standard notation for a matrix of order m cross n, that means it has m rows and nth columns. So if we say that, if you see that this is second row and first column entry, so it correspond, this is second row and first column entry, so this is the intersecting element, so this is denoted by A21. So if it is written Aij, it means this is ith row and jth column entry. Now let me discuss row matrix. Any matrix in which if you have only one row, then that matrix is called as a row matrix. For example, so if you see that in this example you have 1 row and 4 column. Another example, 1 row 3 columns. Okay, so such type of matrix are called as a row matrix. Similarly, column matrix, that means if you have a matrix in which you have only one column, then that matrix is called as a column matrix. For example, so this matrix has 3 rows and 1 column. You can take another example. This matrix has 5 rows and 1 column. So such matrices are called as column matrix, square matrix. So a matrix is said to be a square matrix if number of rows and number of columns are same. That means any matrix of order 2 by 2 or 3 by 3, or in general if you talk about of order n cross n, then such matrices are called as square matrix. So for example, this is a square matrix of order 2. And this matrix has 3 rows and 3 columns. So this is a 3 by 3 matrix. So this is a square matrix of order 3, and so on. That means if you have number of rows and columns are same in a matrix, then that matrix is called as the square matrix. So if you see, this is called as main diagonal entries, or sometimes it is called as principal diagonal. So keep it in mind that we talk about the principal diagonal when we have a square matrix, and the sum of the main diagonal entries, this is called as trace of the matrix. So what is trace of a matrix? The sum of the main diagonal entries. That means we can find trace only for square matrices. So for example, the trace of this matrix is what? Sum of main diagonal entries, which is. Similarly, trace of this matrix B is what? Sum of main diagonal entries. It means trace of B is 3 plus 0 plus 2. Now let's discuss about null matrix. It is also called as a zero matrix. So if all the entries of a matrix is 0, then that matrix is called as a null matrix. Either it is a row matrix or column matrix or any rectangular matrix or any square matrix. That means if you have any matrix whose all entries are 0, then that matrix is called as a null matrix. Now, equal matrices. Two matrices A and B are said to be equal matrices if first condition is they are of same order. That means the order of A and B are same, and the second point is that each corresponding elements are equal. For example, so we will say that matrix A and B are equal if you see that corresponding element W is equal to 4. diagonal matrix. So a square matrix in which all the off diagonal entries or the elements are zeros is called a diagonal matrix. For example, this is a 2 by 2 matrix. This is your main diagonal. So all the off diagonal entries are 0. Then that matrix is called as a diagonal matrix. So this is an example of a diagonal matrix. So let us see another example. In this matrix, this is your main diagonal. So all the off diagonal entries are 0. That means this is the example of a diagonal matrix. Now if we impose one more condition on the diagonal matrix, that if in the diagonal matrix, if all the elements are same, then that matrix is called a scalar matrix. For example, this matrix A is a scalar matrix. This is also a scalar matrix of order 3. Now one more thing, if you have a diagonal matrix in which all the diagonal entries are 1, then that matrix is called as the identity matrix. Means what? You have a diagonal matrix whose all the diagonal entries are 1. So this is a diagonal matrix of order 2. So this is the identity matrix of order 3. Now we will discuss some operations on matrices. So first operation is scalar multiplication. Suppose you have any scalar alpha and you have a matrix A of any order. So alpha A is denoted as, just you have to multiply each element of matrix A by this scalar alpha. So this is called as scalar multiplication. So for example, if you have matrix A as 2 1 3 minus 1 0 4, and if alpha is 2, then alpha A will be, A is, multiply with each element, you will get. So this is scalar multiplication. Second operation which we will define, so you can add or subtract of 2 or more matrices if they are of same order. That means order must be same for this operation. So if you have matrix A and B, they should be of same order. Otherwise the addition or subtraction will not exist. And how we will do these operations? So let us see with the help of an example. Basically we will do the component wise addition or subtraction. For example, you have matrix A as minus 1 0 1 1, matrix B is 6 9 7. So addition of two matrices A plus B, so component wise addition. So first element of this, first element of this, minus 1 plus 6, second element 0 plus 9, 1 plus 7, and 1 plus 12. So this is as simple as that. Now multiplication of matrices. So the product of two matrices A and B is defined only when number of columns in the first matrix is same as number of rows in the second matrix. That means if you have to find the product of matrices A and B, then number of columns in matrix or in the first matrix A, it should be same as number of rows in matrix B. So what does it mean? It means that if suppose you have a matrix A of order 2 by 3 and matrix B is of order 3 by 4, then first we will see that the product is defined or not. That means the product exists. So we have to see A dot B, 2 rows 3 columns, 3 rows 4 columns. So you see that these internal numbers, because this is denoted by row, this denote column. So number of columns in the first matrix must be same as number of rows in the second matrix. So here A dot B is defined. But if we talk about B dot A, so matrix B is of order 3 by 4, A is a matrix of order 2 by 3. So column of first matrix is 4 and row of second matrix A is 2. So they are not equal. That means B dot A is not defined or the product does not exist. So we have to take care of this condition. So now let us see with the help of an example how we will do the multiplication. Now let us see an example how we will do the multiplication. So first we will see that the product is defined because number of columns in the first matrix is same as number of rows. So the product is defined. Now let's do the multiplication. So how we will do the multiplication? Take this row and this column. Now do the multiplication component wise. First element with this, second element, first row, this column. So multiply with this 2 with this 1. This is 2 plus 1. Multiply this row with this column, component wise multiplication. 2 into 0 is 0 plus 1 into 2 is 2. Now this row and this column. So 3 into 1 plus 4 into 0. This row, this column, 3 into 1 plus 4 into 1. This row, this column, component wise multiplication. 3 into 0 plus 4 into 2. So this will be minus 2, 3, 2, 3, 7, 8. So this is how we define the multiplication of two matrices. So there is one thing to note, that the product AB is defined as this, while product B dot A not defined. Why? Because the order of B is 2 by 3, order of A is 2 by 2, and their internal numbers are not same. One more thing about the product of two matrices, that if you have two matrices A and B, and if the product AB and BA, they both are defined, then the matrix A and B are square matrices. That means if the product AB and BA, they are defined, that means they are square matrices. But in general, remember that AB and BA, they are not same in general. And also, if you have the product of two matrices as 0, that means this is another property, this is another property. So if the product of two matrices is 0, then it does not always means that either A is 0 or B is 0. For example, if you take matrix A as, then if you find A dot B, so it will be, so you see that here the matrix AB is 0, but A is not 0, or even B is not 0. And even if you find BA here, so you can see here that AB and BA, they are not same. Now let's discuss some other concept related with matrices, such as transpose of a matrix. So what is transpose of a matrix? Suppose you have a matrix A. The transpose of a matrix denoted by A transpose is the matrix So A transpose is what? Just it is a matrix A which is obtained by interchanging the corresponding rows and columns of the matrix A. For example, if you have a matrix A is this is a 2 by 3 matrix, 2 rows 3 columns, so A transpose will be change the first row to the first column, so first row will become first column, second row will become second column. So what will be the size of this matrix? It has 3 rows and 2 columns. Okay, that means if you have a matrix A whose order is m cross n, then the transpose of the matrix will have order n cross m. So there are some properties. So first property is that if you take the transpose of the transpose, you will get the same matrix A. Second property is that if you take the transpose of the addition of two matrices, you will get A transpose plus B transpose. If you take the transpose of the product of two matrices, it will be B transpose A transpose. So these are some basic properties, and you can verify it very easily. Let me do it one. You can check the other one. For example, if you have matrix A, find this transpose. First row will become first column, second row will become second column, Again, if you take its transpose, first row will become first column, second row will become second column, and if you see that this matrix is same as this matrix, so the first property is satisfied. Similarly, you can verify the other properties. Now let us discuss about symmetric matrix. A square matrix A is said to be a symmetric matrix if you take its transpose. It will comes out to be same as A. If this condition is satisfied, then this matrix A is called as symmetric matrix. For example, this is the symmetric matrix. You can verify it very easily. Take its transpose. First row will become first column, second row will become second column, third row will become third column. So if you see that this matrix is same as this matrix, so this is equal to, so condition is satisfied. That means this matrix is a symmetric matrix. Now, what is skew symmetric matrix? So a square matrix A is said to be a skew symmetric matrix if you take its transpose. It will comes out to be negation of the matrix A. So any square matrix satisfying this condition is called as skew symmetric matrix. So let us see an example. If suppose you have a square matrix A, if you take its transpose, first row will become first column, second row will become second column, third row will become third column. It is nothing but the minus times A. So A transpose is minus A. The condition is satisfied. It means that this matrix is the skew symmetric matrix. Now let's discuss what is upper triangular matrix. So a square matrix is said to be the upper, respectively the lower triangular matrix, if all the entries below, that means for upper triangular matrix, if all the entries below the main diagonal are zeros, then that matrix is called as upper triangular matrix. Here one thing is worthy to note, that we are not talking about anything the entries on the main diagonal. Below the main diagonal all entries must be zero, then that matrix is called as an upper triangular matrix. And if we talk about lower triangular matrix, so above the main diagonal all the entries are zeros, then that matrix is called as the lower triangular matrix. Let me give you an example. This is your main diagonal. This is main diagonal. All the entries below the main diagonal are zero. So this is an example of a upper triangular matrix. You can check another example. This is your main diagonal entry. All the elements below the main diagonal are zero. So this is also the upper triangular matrix. Now for the lower triangular matrix, suppose you have matrix B1 as this is your main diagonal entries. All the entries above the main diagonal all are 0. That means this is your lower triangular matrix. Similarly, if you see that again it is satisfying the condition for the upper triangular, this is your main diagonal, all the entries below the main diagonal are 0. That means this is your upper triangular also. Okay, so there is no restriction on the diagonal entries. This is your main diagonal, all the entries above the main diagonal are 0. That means this is again your lower triangular matrix. So you can check that if you take its transpose, so first row will become first column, second row will become second column, and third row will become third column. Now if you see that this was your upper triangular matrix, and if you see its transpose, this is your lower triangular matrix. That means the transpose of an upper triangular matrix is the lower triangular matrix. Similarly, the transpose of a lower triangular matrix is an upper triangular matrix. Addition of two upper triangular matrix, it will gives you again an upper triangular matrix. Addition or subtraction of two lower triangular matrix, it will gives you again a lower triangular matrix. Similarly, you can check for the product.